Hey everybody, this is Larry. This is day 6, right? Day 6 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and today's problem set and everything. Um yeah, things are loading as you can see. Yeah. Today I have not worked out yet. I am going to go for a run after this, so we will see. And we have a hard problem, a difficult problem. So hopefully it won't take that long because I don't want to go for my run that late. It's an easy one today, only 10 miles. So we will see how, but like a easy 10 miles, unlike yesterday's hard 10 miles. So it should be, it's time consuming, but not, shouldn't be that bad. Yeah. But yeah. Anyway, let's take a look at today's problem. Hope everyone's having going to have a good weekend and all these good things. Yeah, excited. All right, let's take a look. Today we have 3495 minimum operations to make array elements 0. Did we do this? Like recently-ish? This was like only half a year ago. I mean, I don't know. It's kind of weird because I feel like hard problems in recent contests are just like too ridiculous for normal people anyway. Like in general, maybe not this one, but I mean, though I did get a little bit spoiled in seeing that I got 4 wrong answers. So we'll see how that goes. But so I don't know. I feel like at a certain point, I don't know what they're trying to do. Like, is anyone actually learning? Maybe, but is it anyone actually learning anything that useful or helpful for interviews or anything? I don't know, right? But all right. That said, let's get started. I don't know. I think I'm just like way disillusioned in general with Leetcode, but maybe this comes out. Anyway, okay. We have 3495 minimum operations to make array element 0. You're given 2D array queries. Queries is left and right. Okay. Yeah. Each query define an array of numbers consisting from L and R, left and right inclusive. Okay. In one operation, you can choose 2 integers A and B from the array. Replace them with 4 A's over 4. Yeah, 4 of A over 4. Man, they really made that so that it's hard to say. 4 of A over 4 and B of 4, B over 4. If you got that, then good for you. Your task is to determine the minimum number of operations required to reduce all elements of the array to 0 for each query. Return the sum of all elements in all query. Do we get the... What is the nums array? What's the initial array? Did they mention it or am I just blind? Number all elements of the array. Did they give you the array? Huh? I mean, what? Am I missing something? I mean, I'm clearly missing something, but am I missing something that they mentioned? Or am I confused? I see. Give me a second. I'm going to sneeze. I know these queries is such a random thing for this, but... Oh, shoot! Excuse me. Oh, excuse me. Okay, I see. I think I was a little confused because... Okay, I see. So basically, each query has its own nums. I see. Oh, excuse me. Ooh. Okay, and you're able to do 2 arrays, right? I mean, I think the first thing to do is that for each of these, well, there's an observation, right? The observation is that it's contiguous. That's one. And what does that mean when it is contiguous? When it's contiguous, that means that everything kind of collapse in a good way, I suppose. What I mean by that is, well, is the second thing that I was going to say, which is that you could reduce each query by just the number of things, number of operations that it takes to get to 0, right? For example, 1 takes 1 operation to get to 0. Is 0 an input? No? Okay. And if you have like, I don't know, 4 to the 10, then maybe it takes 10 or 11. Maybe off by 1. 4 to that takes 11 operations, and you just store that. And combining them, that means that in an interval, a lot of them will overlap, right? There's no jumping. What I mean by that is that it's a property of the input. I don't know how to exploit it yet, but there probably is, right? For example, let's just say instead of storing the original numbers, we just store the number of operations it takes to get to 0. Then now you have 2, 2, 2, 2, 2, 2, maybe it won't have that many 2s just because that's how numbers work. So you have something like this, but you cannot skip from 2 to 4, right? So then there maybe is some properties there that we can take advantage of. And as a result, I mean, I think this is a problem also. I guess that's why they structure the queries like this, is so because then now you have to do each query really fast because there's 10 to the 5th query. So you could do maybe like a log n type thing, but you cannot simulate, right? Because if you don't have only one input, then maybe it's simulate. So you have to answer each one of these queries very quickly. For me, it just seems like it would be a math problem, and a little bit of a cheating alert, right? Is that, like I said, I maybe I shouldn't have done this. I mean, I still don't know what the answer is, but maybe saying 4 wrong answers is a hint that if I have to guess, and I don't remember this problem at all, honestly, so it's not memorable, but if I have to guess, is basically the reason. Well, what I would do is that what I would attempt to do is just like, now that you kind of see this, now you could combine them into a frequency table kind of thing, right? You could just, maybe not a frequency table necessarily, but you got just like 4 2s, what is it, 6 3 or whatever, right? Like you just combine them together, right? And then the next thing after that is noting that for 10 to the 9, that's 2 to the 30 or 4 to the 15, right? If it's 4 to the 15, that means that in this frequency table, there are only 15 different elements, and you just try to combine them in a good way, right? Actually, maybe the 15 is interesting. And because I was going to say, with the 4 wrong answers, I would have guessed. I mean, if I didn't know that I had 4 wrong answers, I would have maybe guessed some sort of greedy on this type of thing. And the greedy will allow you to just figure out some maths that work on it, right? Maybe it's just match all the 2s and the 3s and the 4s, but I don't know. Well, actually, then now it comes back to the contiguous part, maybe. But the reason that I say the contiguous part, and I this is very sketchy, but the reason why I say the contiguous part is because what I was going to say is that if you have like maybe there's some matching in that. Let's say you have 3 and a 6 for whatever reason. You could do a 2 2 2 and a 3, right? So you can basically kind of match the 6 of the 3 3s in a way, right? Maybe I did so that you will not match the 3 of the 3 because well, it's just that it's not as efficient, right? With this one, to get them into like being as close to 0 as possible, because if you keep on matching all the 3s, eventually you run out and then you can't even do it, right? So that's kind of the idea that I was thinking, but maybe that's not possible now that we have contiguous, right? Because we have 4 4 4 4 5 5 5 5 5. So then as a result, then maybe you just do it this way or something. I don't know, right? And then now you do it that way. Then now everything looks a little bit cleaner. But then now I have to do the math, and I don't know that I know the math, but I'm just saying, these are the ideas that I would think about. And knowing that the past Larry, and I know past Larry, but you might not. That's why it's a little bit of a hint, is that like seeing that I have 4 wrong answers, I probably have a tendency to do certain things that are sometimes wrong for certain scenarios, and maybe I'm just guessing them. I don't know, but okay. Instead of figuring out in a meta way how to solve this, we can just keep going, right? Which is that, okay, now that we have contiguous, I'm not gonna lie, like I said, the first idea that I have is going to be greedy, right? What would greedy look like? I mean, greedy would be just matching all the 2s with 2s, 3s with 3s, etc. And then whatever you have left over, you do maths on it. But as we said, I don't know if, well, a key thing to note is that what are the power of 4s, right? It's going to be 1, 4. So that means that everything. So zero operations is going to have one number, which is just. Oh, sorry. One operation is going to have just one number. Oh, actually, no, I'm wrong. Right? One operation is going to be 1, 2, 3, 3. Maybe we could say, yeah. And then 2 operations is going to be 4. Because that goes to 1, and then all the way up to 15, right? And then 3 is going to be 16, because it goes from 16 to 4 to 1, and then 0, right? All the way to, I imagine, 64 or 63, right? So then what are the ranges here, right? This is 3, this is 9, actually technically 10, actually, right? Am I machine numbers? No, what the 15 minus 4 is not even 9. I am just fine, right? And then this is like 48 or something, right? Yeah. Which is fine, right? And then, you know, you just do the math, and then this comes out to be like, what is it? 182 or something? I don't know. Do we need a calculator? Oh, 192. What is it? Oh, I forgot to carry. But stuff like that, right? That's why when I need. Okay. But what does this mean, right? That means that in the in between, there's no way to get like basically every in between interval will be even number of them, right? So that means that you only care about, I don't know if it's you only care about, but the only discrepancies if, like, you know, depending on your the query interval, the beginning and at the end. And then the question is, how can I take advantage of it, right? That means that at most at the, I mean, in the beginning there could be more, but that means that at the, Is greedy fine? As long as you get the max? Maybe? I'm gonna try it. I don't know. Maybe greedy is fine as long as you get the max. I think the one greedy is just to kind of match the same with the same, and then, you know, just have this one left over and then do it that way. But or maybe not. Maybe we should be able to do it, right? So then now, all right. I think for now, maybe I will YOLO, and maybe I'll get another 4 wrong answers. But that's basically the idea that I'm gonna have, right? Basically, yeah. 10 to 9 is too big, but what we want is current is you go to well, actually, for left, right, in queries, right, and we have to answer, right? Oh no, is this, what is this? Oh, return the sum. Okay, that's what I was like, wait, it shouldn't be an array. I don't know why they do it that way, actually. Why don't they just return an array? That's pretty easy to do. I don't know, very weird. But anyway, so current we set to, there's no 0, so 3, right? So then now, let's just say we have f, I don't know, we'll just put in the counter for now. I know it's slightly less efficient than like just having an array of 15 elements, then I don't have to think about it, right? And then now, yeah, I just say, I mean, we said 15 is the upper bound, so we'll just set it to 20, keep it simple, right? Okay, so then now, if because basically now we're trying to figure out how many numbers are in this range, that is whatever, right? So then now we want numbers between How do I want to structure this? I guess it's fine. I guess we can set it at 1, 4, and 16 instead, right? So then now we have and then now that means that the current range is going to be current and then current times 4 minus current, right? Which is, well, current times 3 minus 1. Wait, is it? Am I doing well? Well, that's the total size of the. That's this number. It's current times 3, but yeah, to get the actual range, left is this, and the right is just current times 4. Okay, right. So then, yeah. How do I get an intersection again? I forget. Right. So basically, current. Let's say current left is equal to 1. Current right is equal to do we want it inclusive or exclusive? Let's just say right. Why am I so bad today? I need a nap. But yeah, basically what I'm doing now is that, okay, given this, we just try to figure out what is the intersection of this. And this, of course, only takes 20, but I'm just really bad at it today, apparently. Right, because it's like, yeah. Because I mean, it's not that hard. It's just that there are 4 scenarios, and I'm trying to think if I can write this in a cleaner way instead of iterating. Is it 4 scenarios? I mean, maybe more, but there are a lot of if statements if I want to do it that way, and I'm trying to think through what's like a not dumb way of doing it. But okay, let's just actually maybe just keep current. Maybe that's fine, right? So then now, if current is greater than left or equal to, right? Then now, okay, let's just say count is equal to 0. Actually, let's do. We'll keep this as. No, this is. This is very awkward. Okay, yeah. From the left side, there's going to be this, right? So it's greater than left. No, the other way. No, this is right. If the current number is greater than left, what does that mean? Why am I so bad at this? Okay, so given a range, this is current. I think it's the other way, that's why. My thinking skills is just not the way it used to be. Okay. I mean, I think the better. I mean, because I think what I'm trying to do is just prefix sum. So okay, let's just do prefix sum. I think that's probably the cleaner way of getting it. Let's just say left f is equal to or f left is equal to get left. F right is equal to get right, and then we just fr minus fl, right? So maybe we could even just put in a helper function. So we have get x, and then prefix sum is because intervals are a little bit trickier. So maybe I should have done it this way to begin with. So right. So then now we're gonna say yeah, in range of 20, say. If x is greater than or equal to 4 to the I, then okay, let's say it's 100. How do we want to represent that? I'm just trying to think about how to representing. Put 100. Because it's not 100 and then 25 and then right? It's actually, you have this structure. I think I want to keep. Sorry, friends. I don't know why I'm struggling so much today. I'm not like my struggle to content ratio is worse for Daily Bomb, but basically, yeah. Okay. If this is the case, then yeah, then f of I is equal to either x minus this, or well, no, it's max, right? It's okay. So let's say the number is 10. What am I getting? If I'm 10, then this is 3. Then the max number is going to be 4 to the I minus, well, this times 4. So this minus 4 to the I, right? That's what we were saying. So for 1, so then this would be 3, hopefully. And then this is just, yeah, right? I think this is right, maybe. Okay, let's print it out real quick. Okay, well, I mean, that's not actually, I guess it's 1, 2, so actually that's not, that maybe is, no, it's still not right, right? So x for 0, oh, whoops. For some reason I thought it was 1, but okay. So for 1, you want this to have, I mean, this is fine. We're probably off by 1 here anyway. But this, we want it to be 1. So actually, it's this plus 1 because it's inclusive. I think that's the part that I missed. Okay, yeah. Then 2, 2, 2, and then, okay, I think this is now right. Struggled, but yeah. So 2 numbers of 1 operation, 3 numbers of 1, and then, yeah. And then maybe we could try, say, 192 or something. 193, just make it a little bit whatever. They messed it up. Oops. Right, so okay, so this looks kind of okay, right? Yeah, I mean, it should have been plus 192, not, but so it looks okay, right? Okay, so then now we get the left, we get the right, and then we just, you know, have this, which is the delta, which is kind of what we want, right? Because then now you have 1. Am I off by 1? I may be off by 1. Yeah, because we want it to be inclusive, so it's going to be left minus 1. So I think it's off by 1, yeah. So then now 1 and 2, we have this. This is 2 and 4. So we have 2 and 3 at the 0, and then, yeah, and then here. So we want this to be I plus 1. I'll just fix that real quick. We can actually also simplify the powers and 4 stuff, but I just wanted to keep it dumb for now. Okay. And then now what? Okay, now, because there are only 15 numbers, we can actually just, now I think we can do greedy, right? So then, maybe I was just reading slow. Okay, so then now we have f is equal to this. And then total, let's just say we call it south of f, and then maybe we go, right? South of f, and basically we want to say for I in range of 20 minus 1, right? So then now we carry, and because it's because the key part about this is that everything is contiguous, so you could just kind of, what I'm thinking of, my current greedy is a sweep line from the big number sweeping to the little number, right? So then so that would have, if f of I mod 2 is equal to 0, then we're Gucci, right? But let's say we have 1, then what happens? Then we have to. I think this is the tricky part, maybe. Well, I mean, there are a lot of tricky parts. I think the thing I would do is. I mean, if it's 0, it's easy, right? Because you just kind of move everything over, right? Like a shift and add thing, right? So let's actually make it only go to 0. So when we are at 0, we could double check. So we should only have one number in that case, right? And remember that if mod 2 is equal to 1, then you know. But yeah, anyway, we just do this divided by 2, total, right? And we are okay. What if it's odd? If it's odd, I mean, this is still probably true, right? But then now, we also want to take one more of the numbers, but which is not always possible, right? So we have to get a one number from anywhere, and we probably ideally want it in a greedy way that we want the next max number. Which we can probably do another for loop if we have to, but 10 to the 5th times 20 times 20 maybe is a little bit cutting it close. But yeah, I think now would be a good time to get the next biggest number. Yeah, I forgot. So this is part of the property that I keep forgetting, which is that it is continuous, right? Contiguous and continuous. And what I mean by that, because I was still thinking of cases of like okay, let's say, you know, maybe I was thinking of f of 10 has like some big odd number, and then, you know, we have f of 2 is equal to, you know, 3 or something. So I'm trying to find, like, match this odd number with this one. But again, Larry, you keep saying this, it is not possible. Or not that it's not possible, but the way that I structured this is that my assumption is that f of 9 is 0, they're all 0, so then you have to do some like weird math to look ahead to the 2. But now again, this is continuous, Larry, right? So if it's continuous, that means that this number cannot be, I mean, if it's 0, that means that if it's 0, it means that everything else is gone haywire. So I think we are able to just, so there are two scenarios, I think, at least, maybe. One is that if this is a big number, then we can just go, okay, well, we just send this to 2 and then set one of these, right? Well, actually, I think maybe this math is, but basically what I want to do is let's say we have this, that means we have 10, 10, 10, 10, 10. We want to set 9, 9, 9, 9 and a 10, just keep it there. But then we want to move one of them to do, right? So then now we have an 8. So then now this converts to f of, oh, also this is not divided by 2. We don't merge them. So I made some mistakes. Oh, I was thinking of another similar problem or something like that. I don't know. Right, so this equal to is equal to 1 or something like that, right? So we can always do that. I think so. That's one scenario. The only other scenario is that f of 10 is equal to 1. Then you cannot match itself. Then maybe you try to match with f of 9. And if that's not possible, then that means that there's nothing else possible because there's nothing after f of 9, right? Because this is continuous. If that's not possible, then you just do one operations by itself. I think that's probably okay. So let's, okay, so if it's even, we just kind of YOLO doing that, right? This is fine, I think. You have to do it. If it's not, then this isn't quite right, right? Because we have to do the mod 1 thing. So okay, I mean, we know that this is odd, so then we just do subtract 1. We do -1 operation, and then now we see if f of I minus 1 is greater than 0, and because we just added this, so then we should already check all this. If this is the case, then we add one more operation. We go f of I minus 2 increment by 1, and then f of I minus 1 increment by 1, and then f of I subtract by 1, right? So something like that. I think there is some like edge cases we have to consider, because for example, this could be I minus 1 could be I minus 1 could be 0, which is fine, but I minus 2 in that case is not fine. So But that means that we could probably, honestly, if I minus 1 is greater than 0, then we can just add it. Because I think that just means that we messed up somewhere. But I don't know if this is quite right, but I think this is good enough for me to YOLO a try. And apparently not. Alright, well, let's see. It's enough for me to at least YOLO running the thing, but alright, let's see. F should be right. I just want to make sure. Oh, yeah, okay. For debugging, I'm going to write if f of I is 0, del f of I. Otherwise, it's just kind of clutter my printing. Alright, so we have 0, you have 2. That seems right. Am I misunderstood? Oh, it's 2 numbers but 1 operation. So here, we can fix that. I mean, this. I think that's where I confused it, because I think here I divided by 2, but actually the divided by 2 should be here, which we did have. But yeah, I think this part is fine though. Okay, still wrong, but you know, because of this part for some reason. Well, that means my greedy is wrong, possibly, right? All right, let's do a before picture. Okay, so you start with this, you get the 2, so it goes to, well, after 1 operation, it should, in my mind, it seems like it should be okay, because this does nothing, right? So then you have this, we do 1 operation. Oh, I didn't have an else. So I don't think it applies to this one though, but I did have an else. We just do and then f of I minus, we just do it by itself, right? But it shouldn't change this because it doesn't make sense. But yeah, because I would imagine that this 1 gets matched with this 1, the 2. One of them goes to 0, and we're happy. We don't operate on 0, right? No, I don't think so. Because that's the terminal situation, right? We could print out every iteration, I suppose. Maybe I didn't need to do it that way, but how do we delete this? Oh, because of I minus 1 is something. Yeah, maybe something like that. Okay, fine. But okay, so you have this. So this is accurate. We moved the 2, 1 with 2 to this. So this one of them is done. We have this. That should be 1 operation. Why is this a 2? Did I mess up the math? Maybe I just didn't mess up the math. Okay, so it's odd number. We have 3. So we move 2 of them to 0. Oh, I just didn't subtract this. Huh. Oh, just set this to 1, I guess. Okay, so now it fixes that one. I didn't think I need... Because the reason why I didn't set it earlier is because I thought I didn't need it, but maybe it actually matters for this particular part. At least the way that I wrote it, maybe. That's weird, actually. But yeah, at least it's fixed now. Yeah, because it goes to There's 2, 3, they're all 0, and we're just Gucci, right? Okay, but we're still wrong on other stuff, which maybe is fine, so we'll see. Hopefully it's not an algo thing. So okay, you have this thing, which is initially 3 2s. Oh no, these 2 things need 1 operation, and then these needs 3, which this represents correctly. And it thinks that I think that it takes 2 operations, but it takes 4. Do I have a divided by 2 here by accident somewhere? Maybe something like that. Like, I don't get why there's a divided by 2. Oh no, that one is fine. Maybe it's something weird. Okay, let's see. right? So as we said, so this is fine, right? We have 3 of these, so we take one operation to but then now we have 1 left over, so then we do another one. So that's why do I this so this took 1 operation. That's fine. No, is it? No, there should be 2. Why am I not adding 1 here somewhere? Okay, so we have 3, right? We have 3 total increments by 1, which is fine. And then now this is true. So then it should total. Oh, I miscounted. Well, not miscounted, but I moved from I to I plus 1. But then now, as we saw, I incremented, but then the I minus 1 also moved from I minus 2, so I don't do that part. That's the key part. I think for this one it's fine because it's just by itself. It doesn't get mashed. Okay. I mean, it's still wrong, but I think that's slightly more precise, hopefully. Yeah. Okay, so then now, well, no, the math is wrong here, though. Because it thinks that this only took 1 operation. So this is 3, this adds 1. Why is it not adding another one if it has to be in one of these 2? Oh, I'm dumb. I did add this thing, but then I add this thing after this thing, or before it. So okay, I have to. That's just silly. I'm making very silly mistakes, honestly. I mean, maybe I have silly mistakes in other places as we'll have, because I am ready to YOLO submit, but those are pretty bad, honestly. Today, like I always say, some days you're gonna have bad days, and it's just that my bad days are on camera. Hopefully this is fast enough. Maybe it times out, but in theory it shouldn't, just because there are only 20 elements. But I don't know. But if it times out, it's actually not a bad thing. It's 643 over 640, so 643 over 646. I mean, obviously it's not a great thing that it times out, but it also means that none of the previous numbers it's not incorrect for any of the previous things. That means that at least in a way it gives me confidence in the correctness, if not the timeliness, right? And also, like I said, there's a easy optimization that I kind of just was a little bit lazy on. One is kind of doing this thing, right? Times 20, and I think that should be mostly good. I have to it's either 20 or 21. But let's put that in somewhere. Whoops. Right. But as a result, maybe this is going to be m plus 2 or something like that. Yeah. So that's that, and then maybe here we went out to so we could get like an array difference, which is fine, right? We could even just return F1 because I'm too cheap to reallocate the memory, right? Maybe it's, yeah. Like we're talking about efficiency anyway, right? So this is a little bit faster. I guess we could actually, we should probably have benchmarked it beforehand. But we'll see how fast/slow this is first. Hopefully not. Oh, 1.3 seconds is actually slower than I would like, to be honest. Is there anything I can do? I mean, this thing is a little bit messy looking, but anyway, let's YOLO submit a little bit. We'll see how much progress we make, and then you know, if it's still too slow, then we'll just optimize it. But it looks like it is fast enough, and here we go, 1985 day streak. The good thing is that, I mean, I don't really count the time limit exceeded, just because that's already, I don't even count it as my fault, honestly, because the complexity is the same, right? We did save 3 seconds or 4 seconds or whatever the time limit is. again, I don't care about that. There are some more things we can fix, like for example here, the powers of force, because for this get, we call this get a lot of times, and these powers of force kind of add up. We can actually probably put it here. I mean, as a fun thing, we'll add some optimizations here as well, right? So maybe we have one, right? So then power 4 dot append, something like that, right? And we don't even have to put it inside, we just put outside. And then now we can say, hopefully this is, power 4 of I, right? So easy optimization here. You can see that it went from like 1.3 seconds or whatever it was to like 900 milliseconds. So it should be faster. So it was, here we're doing some optimization, and it's fine. Like the time limit is not great, but at least we didn't prematurely optimize, right? As I said, time limit exceed is actually a good thing in the sense that at least we know that we're correct. And like what did I do last time? Why did I have 4 wrong answers there? Actually, I'm not gonna lie. I did think about this case, and then I was like, this cannot be fast enough. I guess maybe you could prematurely do it, but this is what I would have done if I did not remember or keep on reminding myself that that is continuous, right? Because otherwise, then you could maybe do some shifting with an odd or whatever. There's one more optimization that I would make is probably just doing this f min instead of min, or at least one easy one. We could probably look into it and find ones to remove we really want to. I think this one is one of the easy ones. It's not as impactful, but it is m times q number of mins, so it's going to be slightly faster for sure. Yeah, and you could see that bears out. And people sometimes ask me why, and well, that's why. Like I think this part, there are probably some things we can do to make it a little bit faster. I don't even know if this makes sense anymore, honestly. Why does that? Actually, I mean, definitely does not make sense anymore. But I'm surprised that it doesn't like complain, huh? Because I don't know that I ever used del on a thing before, but yeah, right. So even faster because that operation probably did nothing, but I wonder if this shifts things over. I don't actually have no idea what it does on an array. I mean, maybe that it just shifts things over like in a, like how, I guess that's how you, I don't know. I don't actually know what it does. But yeah. So actually we got on the first try-ish. Like the time limit exceeded was just me being lazy with the frequency table. But I was worried more about correctness than timeliness. Especially, well, like I knew this was going to be fast enough. It's just that I also knew that that was probably a little bit sketchy in terms of things that are fast enough, because you cannot be that much slower. But yeah, what's the complexity? Let's go over it again. This is O of Q, right? Number of iterations. What is the get function? One of the get is a prefix something, right? And this does O of M loop, where M is the number of, or technically speaking, half of the number of bits because it's power 4, right? And also that space. So we do it twice, and then delta also is the third time really of O of M. And then total for south is also O of M, as we saw. We just kind of go, sweep line all the way. Well, how did I do it last time? Actually, I mean, I was faster last time, so maybe I did even more optimizations or something. Did I actually do that with the bit mask? Wow, so the bitmask solution did work. Maybe that's just lucky, huh? I mean, I know what I did here. Is that is a different way of doing it, though. Obviously, the reason why bitmask you can't do bitmask per problem, but yeah, it is just because you have to add the shifting logic. That's probably part of the wrong answer. The thing to take advantage that makes it fast enough is that bitmask is like you could reuse it on the entire input, but actually I didn't expect that to be. I mean, one is that I'm surprised it's a little bit faster, And then the second part that where's my thing? I'm surprised is that it is, yeah, because and I just converted to also using this. Oh wait, no, this is what I did this time, I guess, actually. Oh, this is so much cleaner than the way that I was thinking about it. I mean, programming wise, I think my code is cleaner, maybe, but this is thinking wise, this is cleaner. But also, this is just greedy, apparently. Oh, that is so much smarter, actually. Yeah, I mean, okay, yeah, wow. That is so much smarter. Okay. So that, I mean, yeah. I mean, it's kind of similar to what I did here, but this is taking it one step further than the thing I did today. And the thing that I did today is, and I don't know that I explained it that well, but I just kind of do it sweep line, right? Like one by one, I take the biggest group of numbers and then I move them to the right. But if you kind of just aggregate them all together, every number has to move to the right once. So with another number, hopefully, and it doesn't matter. Like, so all together, it would just be this formula. Oh, that is so much cleaner. Yeah, because then now in that case, well, I mean, this is actually the same code as I have now, except for that this instead of simulating it out, just doing the math all together. And what I mean by that is that, for example, I mean the way that I did it today is that I just do it one by one, or two by twos, I suppose, or like in batches of groups, which is fine maybe. But the idea here is that, okay, if you have like a set of numbers that takes this, it doesn't matter how many which numbers you take. It means that this will, when paired with another number, or if you want to multiply the number of things that gets moved, and then divide them by 2, and because it works again because this is continuous, so you don't have this awkward like unbalanced situation, right? Because in a similar situation, you can imagine that it gets unbalanced if you have like, I don't know, a really big number, 5 and 5 and 5 or whatever, right? You have to kind of match this. I mean, even then you can do it in a good way, but it gets unbalanced by this number, so you have to be careful. And because of continuous, that's not happening anymore. So the only thing that can happen is that you have just like an odd number out, and you just have to compensate for it. Wow. I mean, I got most of the way there, but I did not make that optimization. But also, like, it wasn't needed, right? As you saw, because this is, I mean, this is definitely slower than this, but it is, fine, I suppose. Anyway, yeah, that is all I have for this one. Let me know what you think. This is O of Q times M, by the way, in case you're curious. Or I don't know if I mentioned it out loud. Time and O of M space. Yeah, which is mostly constant, you could say, assuming that you want to reuse stuff or whatever. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. Have a great weekend, everybody. I'll see y'all later and take care. Bye-bye.